क्योंकि it's a very important law for electrical engineers and particularly for electrical machine subjects. Faraday's law of electromagnetic induction, and the second rule is a force on a current carrying conductor in a magnetic field. So these two laws are very important for you people. Faraday's law of electromagnetic induction for generator, and force on current carrying conductor in a magnetic field is for electrical machines. All of the electrical machines are working on force on current carrying conductor in a magnetic field rule, and all of the generators are working on Faraday's law of electromagnetic induction. The third law or rule is Lenz's law. That is another phenomena within the electrical machines and generators. Understand my point? So the first law is Faraday's law of electromagnetic induction. According to the Faraday's law of electromagnetic induction, when we move a conductor in a magnetic field such that, like such movement of the conductor, when this conductor cuts the magnetic flux or magnetic lines or magnetic field, the EMF or voltage will be induced in that conductor. Understand my point?
Yes, sir.
So that is the basic law. Whenever the conductor cuts the magnetic flux or flux cuts the conductor, doesn't matter. We are very much interested in cutting the flux by a conductor. क्लोज होना चाहिए, तब उसमें जो है करंट फ्लो करेगा. लेकिन यहाँ पे मैं कुछ और आप लोगों को समझाना चाहता हूँ कि फ्लक्स कट जब कट होगा कंडक्टर, जब कोई कंडक्टर फ्लक्स को कट करेगा या फ्लक्स कंडक्टर को कट करेगा, मतलब आपने कंडक्टर को स्टेशनरी रखा है, फ्लक्स को मूव किया है, या मैग्नेटिक फ्लक्स को स्टेशनरी रखा है, कंडक्टर को मूव किया है, डजंट मैटर. दोनों केसेस में फ्लक्स, कंडक्टर ने फ्लक्स को कट किया है. सो द ईएमएफ और वोल्टेज विल बी इंड्यूस्ड इन दैट कंडक्टर. इंड्यूस्ड तो वही जब केबल का ना गिरी के ऊपर ना, and what will be the value of that EMF? The value of that EMF will be EMF is equal to BLV sin theta. Correct?
Yes, sir.
And what is this B is for? Magnetic field density. What is this L for? Length of the conductor under that magnetic field. So magnetic field से बाहर होगा. If there is some part of that conductor is out of the magnetic field, we will not consider that in this L. This is the length of that conductor under the magnetic field, which are actively cutting the flux. And V is for angular velocity. Why angular velocity we are considering over here? Because in generators, in machines, all the armatures are rotating, in a circle or, round in a 360 degree. So that's why angular velocity we are considering over here. RPM, revolutions per minute. Understand my point?
Yes, sir.
So all of the generators, and what is this theta? What is this theta for? Angle between the conductors and flux. Because sometimes these conductors are very parallel to the flux lines, so there is no cutting of flux by these conductors. Understand my point? So here it is, for example, this is the field. So we are providing a magnetic field over here with the help of windings. Understand my point? Whenever we energize this field, these windings with a voltage, there will be a magnetic field inside this stator. Magnetic field will be. If we energize these windings with alternating voltage or AC voltage, there will be an alternating magnetic flux inside this. And if we energize this stator or windings with a DC voltage, there will be a permanent is another case, And whenever we energize with a DC voltage, there will be an unchanging or direct flux. What does it mean? That constant, not constant, like not changing the poles. Poles बना चेंज कहीं छे पर नॉर्थ के नॉर्थ है तो नॉर्थ है साउथ है तो साउथ। ये डीसी में है। और अगर एसी में इसको हम एनर्जाइज करेंगे साइकिल के साथ वो आपके पोल्स cycle, whenever a cycle changes its position or polarity, there the magnetic poles will be changed also. Understand? And then we are using that qualities or phenomena of AC and DC magnetic field in different machines. Likewise, in three-phase machine, the induction or synchronous, we are using a three-phase supply, AC supply for this stator. And with the help of that three-phase supply, AC supply, we are producing and rotating magnetic field. That is a very helpful phenomenon of that AC voltage producing a magnetic field, which are using in very vast area of electrical machines. Likewise, in synchronous machines are working on that phenomena, rotating magnetic field. Three-phase induction machines and single phase are also working on rotating magnetic field. We will discuss that rotating magnetic field, that how it is useful in electrical machines. Understand my point? So that was a very important law for electrical engineers. And for an electrical machine subject. Faraday's law of electrical